Okay, Assalamualaikum and hello everyone. My name is Mama Zulfahmi Borhan and I'm final year student. For my final year project, the topic is performance of soil resistivity and the ground resistance measurement. So in this project, there are three simulations and the software used is CDEGS software, which is in this software we use Recep and Half-Rep module. So the three simulation is soil model, Wenner 4-point method, and the third is the fall of potential method in Half-Rep module. So the first one, I will start with the soil model simulation in the set module. So in first is data entry. You can see the C1 and P1 is the electrode spacing, and then the depth, and the second is apparent resistance. So for the data entry, we need to refer to the real measurement that have been done at the Petronas Rapid Project in Pengerang, Johor in 2016. So there also equipment and the location that have been measured. The data also show the voltage, current, AB spacing, electrode spacing, and the resistance and the resistivity that have been measured. So the data we will transfer to the receipt and we will do the computation. So for the computation, we can define the number of layers that we want. So we can see that they have the auto generate 2 layers, 3 layers, 4 and others number of layers. So in this project, we will focus with 2, 3, 4, 5, 6 and 7 layers and also a uniform soil model. So for this part, I choose 4 layers and then we will run the simulation. So now we get the and now this is the soil model that we develop with 4 layers and there's a resistivity and the thickness. So this example for the 4 layer soil model. So the next step is we will for next project. So that's all for the soil model. So that's all for the soil model simulation. Now we will proceed with the second part of simulation, which is Wenner 4-point method in the half-rep module. So this is in half-rep module, and I have designed the Wenner 4-point method configuration, which is 2 outer electrode, which is current probe, and this is observation point. We need to measure the voltage. So the soil model, we import or for the soil model, we import the data from Recep module that we have designed before, which is 4 layers, and this is the data. So I have defined the soil data. The next step is define the current energization. For the current energization, this is 0.113, and we refer from the real measurement data, which is 0.113 for the data number 1, and the electrode spacing is 1.0 meter. So for observation point, as mentioned before, the spacing is 1 meter, and for x equal to 1 means the 1 meter is 1 meter from the origin, and 2 meter means 2 meter from the origin. The outer electrode, the first outer current electrode, located at origin, and the length is 0.5 meter. And the radius is 0.067 energized with the current one. The that I've defined before. The second outer electrode also have a 0.5 meter length, and the location at 300 means 3 meter from the origin, and the radius is same, is 0.067. So after we have defined the data, we can run the simulation. So we can see the simulation have no error. So we can see the output 5. So these are the computation results, and we can see the voltage measured at the point, say the point number 1 and point number 2. It has same distance to same electrode spacing, which is 1 meter, and we can take one reading only, which is 6.075. So this is the first reading for number 1 data. So for the second part, we need to change the current probe's length, which is 1.5 meter, and take the reading based on the data, which is the reading is from 1 to 12 with the same electrode spacing, 1 until 30 meter. So that's all for the Wenner 4-point method. Now we proceed with the fault of potential method. So in FRAP module, the another simulation is a fault of potential method to measure that have a grounding electrode under test. The potential probe, but in this FRAP module, we define an observation point and the current probes or the current electrode. So in fault of potential method, we choose the source model from the recept as a single layer P92. So this is the resistivity, and then the same step, which is we need to define the energization type, which is the current in this fault of potential method, or the current is 1 ampere. And then for the grounding electrode, it's located at the origin and the length is 1.5 meter. The radius is same with the Wenner 4-point method, which is 0.0067. For the observation point, there are several points that I have defined, which is 10 meter from the origin, 20, 30, and for the current electrode, the length is 1.5 meter and is located at 100 meter from the origin, and the radius is 0.067. So we will run this simulation after have finished defining all the in a FRAP module. Then we can see that the simulation doesn't have error. You can see the output file. We need to so from the computation result, the same value is 36.4492 or uniform cell model. And then the design for the grounding grid is with the size. So this is the grounding grid characteristic. We have the number of horizontal which is 11, number of vertical is 11, and the width and height is 70 minus 7, 70 times 70. And the radius is for the electrode is 0.067, and also have the observation point that has been defined, which is 0 with 45, 60, 70, and then is the current electrode. Located also at the origin and have the observation point that is defined. So the method is same. We need to define the soil model, which is 36.4392, and then have a current probe located at the 100 meter, and the length is 2 meter, and then the radius is same, which is 0.067. And then we run the simulation to get the voltage. So there is no error for the simulation, and you can see for the voltage from the output file. So in computation results, you can see the voltage, and voltage at the origin is 8.777, and we can get the delta V by calculate voltage at origin minus at the potential point. An example, for voltage at delta V at point number 2 is 8.77 minus 3.295. So from the delta V, we can get the resistance with the formula voltage over current. And the current is the same as before, which is 1 ampere. So that's all for my video simulation for final year project. Thank you for watching. Assalamualaikum.